Alright, what's up? Welcome to another video on linear algebra. So today we're going to be going over determinants. Now determinants is a very important section of linear algebra because you'll be using determinants in basically every class. You just don't know. When you're solving linear equations, you're probably using determinants. Then you don't know. I know in a few of my courses, I've utilized this technique, so let's move on. So a determinant is essentially a real number that is associated with a square matrice. So let's say that, well, let's look at a 2 by 2. Alright, and let's say A is a 2 by 2. And let's say we find the inverse of A, and that comes out to 1 over AD minus BC. And when we flip the matrix, it's going to look something like this. Right? So, funny enough, or maybe it's not funny, this part of the formula to find the inverse for a 2 by 2, this is actually the determinant of A. So the determinant of A is basically AD minus BC. Now, since this is the case, if the determinant of A is equal to 0, A inverse does not exist. And you can know that for sure because if you had 0 in the denominator, obviously it won't exist, right? So if you're thinking, oh, is there an inverse to this matrix? Well, let me check the determinant. Oh, it's 0. That means my A inverse most likely does not exist. All right, so let's go on and look at this. Let's go on and look at this matrix. A is going to equal A subscript 11 A22. All right. So for this purpose, we'll find it convenient to use these subscripts when we're writing the matrices or determinants. So let's look at it like this. Now, when you find the determinant of A for a 2 by 2, it's going to look something like this: A11 times A22 minus A12 and A21. So if you can see what's happening here, what we're doing is basically multiplying these two values minus the product of these two values. All right, now let's look at the case for a 3 by 3. For a 3 by 3, we're going to use basically the method called expansion. And we're going to be looking at cofactors, and we're going to be looking at minors. All right, so if it doesn't make sense with the definition, this definitely makes sense when you're looking at examples. So let's just say we have this matrix, and these are all the components. 32, 833. All right, so we have this, and we're going to be looking at the minor. Let's look for the minor 23. So what we're going to do is let's switch some colors. What we're going to do is we're going to go to that same 23 subscript, and we're going to basically delete that first column that that subscript is in, and then we're going to delete that row that our subscript 23 is in. All right, so now our minor 23 is equal to the determinant of A11, A12, A31, and A32. All right, so now that's very important because what is left over here is A11, A12, and A31, A32. Now that's going to be our determinant. Okay? So this is the method that we use when we're dealing with 3x3 matrices. Okay, so to find the determinant of M23, that's going to be A11, oops, got a little too excited, and A32 minus A12 times A31. Okay, cool. So let's say these A's had numerical values. What you would do is multiply the value that's in A11 and A32, whatever that is, minus whatever this comes out to, right? So just so you know. Also, there's something called cofactors. So cofactor for 23. The cofactor for 23, actually let's, okay, yeah, keep the same page. So we're going to be looking at the subscripts. So if the subscripts addition, if the sum of the subscripts is odd, then we're going to get the negative of the minor. If it's even, then we're going to get the same as the minor. So what I mean by that is we're looking for the cofactor 23. So these subscripts, that's 2 plus 3, which is 5. 5 is odd, believe it or not. So that means we're going to get the negative of whatever the minor for 23 is. Okay? So let's look at a cofactor 22. So if you were to add those subscripts up, that's 2 plus 2, which is 4. 4 is even. So the cofactor of 22 will be whatever you get for the M22. And remember, the M22 is simply the determinant of whatever is left over, right? So if, let me write that down. Okay, so M is So M is basically the determinant. Okay. So we'll go over how we got that determinant again. So let's say they want to know the determinant. They want to know what the minor 23 is. That's how the question will be. What is the minor of 23? So what you're going to do is you're going to go to your matrix, look for the same subscript, so 23, and what you're going to do is you're going to basically not even look at this column and this row. Sorry, I'm going to sneeze. You're not going to look at this column and this row, and you're only going to focus on these values that are left over. Those will be your components for your matrix, and then you're going to find the determinant of that, and then you get this value. So to find your cofactor, that's going to be let's say we're finding the cofactor of 23. we have to add the subscripts, and if we get an odd value, that means we're going to get the negative of the minor that corresponds to that subscript. If we were finding the cofactor of an even number, so like 2 plus 2 is 4. If it's even, we're going to get the same value for whatever the M22 is. All right, let's look at some problems to make that a little more clear. All right, let's take a look at this example. We're instructed to find the minors and cofactors of... So let's go ahead and get started. Let's take a look. If you can hear my dogs, I'm so sorry. I'm human, and I have pets, so I'm like a normal person. So what you're gonna do is, let's say we want to find M13. So we're finding the minor of 13. Okay, so what that means is you need to know where the M13 is. So this was M11. I'm sorry, this was A11, this is A12, and this is A13. Okay, so you're going to be finding the M13. So what you're going to do is you're going to look at that number, and then you're going to delete anything below it or on the side of it. So we're totally negating those numbers. Now what we're going to do is we're going to take the remaining values, which is 6, 7, negative 3, and 1. You're going to put that into a matrix. So it's going to be 6, 7, negative 3, and 1. So that is now the determinant. So now we have to find the determinant. So remember, it's 6 times 1 minus 7 times negative 3. So that's going to be 6 times 1 minus 7 times negative 3. Okay, so what do we get from that? We're going to get that equal to 6 plus 21, right? So that's going to be 27. So the minor of 13 is 27. Okay, so let's look at the cofactor for 13. Now, before we solve anything, we have to know if the summation is even or odd. So that's going to be 1 plus 3, that's equal to 4. So it's even. So that means it's the same value as whatever you got for M13. So that's going to be 27. So cofactor of 13 is also 27. So there we go. All right, so now we have this problem, and we're instructed to evaluate the determinant of the given matrix. And if it's invertible, use the equation to find its matrix. And the equation that they're talking about is basically that equation to find A inverse of a 2 by 2. So, okay, so let's look at this determinant, or this matrix first, A2. So we have this matrix, and now let's find the determinant. So the determinant, 4, 1, 8, 2. Okay, so that's going to be 4... Wrong button. It's going to be 4 times 2 minus 8 times 1. Okay, so that's going to be 8 minus 8, which is 0. Okay, so since the determinant is 0, the inverse does not exist, so it's non-invertible. Right, because if our determinant was 0, then the equation is going to look like this. It's going to be 0, and then whatever junk goes in there. So we obviously can't have that. So that means it does not exist, and it's not invertible. So what if we were to look for one that was invertible? So let's have this matrix: square root of 2, square root of 6, 4, square root of 3. Okay, so that's our matrix. Now let's find the determinant of this matrix. 4 square root of 3. Okay, so what we're gonna get is equal to square root of 6 minus 4 times the square root of 6, and we're gonna get negative 3 times the square root of 6. If you need some explanation, we have the square root of 3 times square root of 2. That's going to be square root of 6, subtracted by 4 times square root of 6. Okay, so here we are. Since the determinant does not equal to 0, that means that the inverse does exist and it is invertible. So we could find the A inverse. Now let's use the A inverse equation for a 2 by 2. So the cool thing is, you already know what the determinant is, so it's basically now the denominator, right? So now you just have to appropriately place these numbers into the matrix. Square root 6, square root 2. Okay, so now if we apply that, if we apply this fraction to every term, we're going to get the A inverse being equal to -1 divided by 3 times square root. We have 1/3. We have 4 divided by 3 times square root 6. And we also have -1 over 3 times the square root of 3. So this is our A inverse, and that is how you find it. All right, now the fun part. So we did the 2 by 2, and that seems to be easy. So let's look at problems using 3 by 3 matrices. Okay, so let's say, for instance, we have A is equal to 3, 3, 1, 1, 0, -4, 1, -3, and 5. Okay, so this is our matrix, and we need to find if it is the same instructions. So find the determinant. If it's invertible, find its inverse, right? Okay, so this part is super important. So we need to think back to our cofactors, right? Our cofactors were basically determining whether the sign was negative or positive. And for the matrix. So I'm just going to put down these signs, and then we'll see how I got them. Positive, negative, positive. Okay, so these red signs are super important because when you're doing the determinant for a 3 by 3, these will come into play. Okay, so we have, let's look at this one. So that's going to be the cofactor of 1, 1, right? So if we add those subscripts, that's going to be 1 plus 1 is 2. So that means, because it's even, it gets the positive value. So let's look at 1, 2. C1, 2. If we add these subscripts, that's going to be 1 plus 2, which is 3. 3 is odd, so that means it's going to be the negative value, right? So that's why we have this negative. So if we look at C13, that's going to be 1 plus 3, which is 4, which is even. That means it's going to be the positive M value, right? And we can go on, and on C21, that's going to be 2 plus 1, which is 3, which is odd. That means you get the negative M value. All right, so that is how I got those signs, and those signs are super important. Okay, so let's go on. Let's stop talking about their importance. Okay, so let's find the determinant. So the determinant is found by picking whatever row or column to delete, and then finding your determinant using those leftover values. So you can pick whatever column, row you want, but a tip for picking the right one is going for the ones that have zeros in it. The most zeros is the best because that value would just go to 0, and so now you're just multiplying and adding either 1 or 2 terms. So I'll show you what I mean by that. So let's go ahead and pick this row. This row. We're going to delete it, basically. I myself, I don't like doing this trick because it'll be confusing sometimes, but whatever. I'll just show it to you. Okay, so we're going to basically we're going to look at this 1, and we're going to delete every number in that column, and then every number in that row. So now we're going to use the numbers that are left over, right? So the numbers that are left over are going to be 3, 1, -3, and 5. Okay, so notice how I put that term, the one that we were deleting, we're not looking at, I put it in front. And actually, I hope you guys caught my mistake, because I did make a mistake. So my mistake was I didn't include that negative. So remember, we looked at the cofactors, and this value was negative. So we have to include that negative. And then we have to look at the next value, which is 0. So we're going to do the same thing with 0, right? We're going to block everything out in that column, and then everything out in that row. And so all we're left with is this, this, and this, and this. But because it's 0, we're going to be multiplying it by 0, right? So that's what I'm talking about, how it all goes to 0. I guess I'll write it down still. We have 0 times the determinant of 3, 1, 1, 5. Cool. So that's cool. All right, now let's look at 4. Oh, and notice that value is 0 as plus. So I put the plus sign, right? Okay, so now let's go to that number 4. The number 4 is actually a negative. So there's 2 negatives, right? So what are we going to do? We're going to block out that column and then block out that row. So we're left with 3, 3, 1, -3. Cool. So those double negatives, obviously plus, and we just have to find the determinants of these guys. So that's 3 times 5, that's 15, minus, which becomes plus, plus 3, okay? So we have -1 times 5 times 3 minus 3 times 1. And then we have plus. You see how this entire term will go to 0? Because you have 15 minus 1, which is 14. 14 times 0 is going to be 0. So that's 0. Then we have plus 4 minus 9 minus 3. Because we multiplied these and then subtracted that one. Okay? Cool. Now we're going to get -18 minus 48. And that's going to equal -66. And now because -66, believe it or not, does not equal 0. So therefore that the A is invertible. Our matrix A is invertible. Cool. So that answers that. All right, now let's look at 1,000 by 1,000 matrix. And let's figure out the determinant. I'm totally kidding. Let's not do that. We have 4, 0, 0, 1, 0. We're just looking at a 5 by 5. 3, 3, 3. We're not gonna completely solve it, I promise. You could do that if you think this will help, but I'm just trying to show something. 9, 4, 6, 2, 3, 2, 2, 4, 2, 3. Okay, so 5 by 5 matrix. Now find the determinant. Okay, so this is where I was saying that picking a row to sort of like start off with that has the most zeros is will make your life easier, because if you start off with this row, so that's the only row that has 3 zeros. This column has 2 zeros, so you might not want to use that one. So this row has 1, 2, 3 zeros, as you can see. So it'll be like the same thing like last time, where the zeros made that whole entire term go to 0. So let's start off with the 4. So you'll have you'll have 3, 3, negative 1, 0, 2, 4, 2, 3. Oops, doesn't look good. 4, 6, 2, 3, 2, 4, 2, 3. Okay, so when you're doing a problem like this, you might want to put your signs before you do it, right? Okay, so remember these zeros, I won't even include them because I'll know they go to zeros, that one goes to 0, but that negative 1, can't forget about the negative 1. Okay, so that will be 3, 3, 3, 0, 1, 2, 4, 3, 9, 4, 6, 3, 2, 2, 4, 3. Okay, cool. So now you have 4 by 4 matrix. So what you'll have to do is the same thing until you're done. So what you're going to do is pick another row, and then you're going to do the same thing, right? For both of these, which is why this one's kind of time consuming. But if you need the practice, this is good for practice. Okay, in my life, I like to make things super easy. That way you don't stress. So let's just look at a couple of theorems. Now these theorems, they will make your life a lot easier. So check this out. In the book that I'm using, it's called Howard. And theorem 2.1.3. Now these theorems say if you have a matrix A which has, let's say it has like a bunch of numbers, right? It has a bunch of numbers, but then it has numbers here, numbers, whatever. And you have a whole triangle of zeros right here. If you were to take the determinant of A, that's going to give you A1, A22, and so on. And if you have numbers, and your zeros here, that is going to come down to so whatever the product of this diagonal is, okay? So that makes my life a lot easier. Hopefully that makes your life easier. So let's look at this problem. A is 1, 1, 1, 1, 0, 2, 2, 2, 0, 0, 3, 3, 0, 0, 0, 4. Okay, so do you see how there's a diagonal that separates like a bunch of numbers, and it has a 0 triangle, right? So what you're going to do is take that diagonal and multiply them. So the determinant of A is equal to the product of that diagonal. So you have 1, 2, 3, 4. Those are all multiplied together. So you'll get 24 equal to the determinant of A. Cool. And that's something to make your life easier. So, I hope you enjoyed that one. We're going to be going over finding the determinants with row reduction next video. So, hopefully you like this one, and if I'm helping you out at all, please let me know. And if you want me to change something, let me know in the comments so that I can do that for you.